Welcome to Special Cases of Systems of Equations. The best way to use this video is to take notes while I'm teaching. Pause the video often to make sure you get your notes down, and every time the video arrives at a you try, you pause the video, attempt the problem, and press play when you're ready to see the solution and the work. In this section, we'll be covering the following topics. Special Systems of Equations. We've spoken earlier in the graphing video about the types of solutions when we look at a graph. You get one solution when you can find the point of intersection. You have no solution if the lines are parallel and will never intersect. And you have infinitely many solutions, or all real numbers, if when you graph the lines, they literally graph on top of each other. But what happens if you don't want to graph it? Maybe you're using substitution or elimination. Well, if you have one solution, that's what we've been doing this whole time. X is equal to some number and y is equal to some number. But if you get a special case like these two here, your variables are going to disappear and you're either going to be left with a false statement like 0 equals 4, and that would be no solution, or you're going to be left with a true statement like 0 equals 0 or 2 equals 2, and that's going to be infinitely many solutions or all real numbers. Let's take a look at a couple examples and then you'll try. So solve the system. Well, we could graph substitution or elimination. I'm going to use elimination. Now you might realize like, hey, there's 3's and 2's, but we'll go forward. We'll multiply the top by -1. Remember to distribute to each term, including that 10. We get -3x, -2y, and -10. Well, that eliminates and that eliminates. So a common mistake is to write nothing, but bring down 0. Place hold that side is equal to -8. Now you can say, is this true or false? Well, that is false. So we would actually write no solution. Example 2. Well, in this case, I'm not going to graph, but I am going to use substitution because I've got one equation that's equal to y. So I'm going to box around it, and because it's y, I'm going to box the y over here. So I get x minus 2, flip-flop those boxes, 1/2 x plus 2 is equal to -4. I'm going to put a 1 on that, 1x. When I distribute -2 times 1/2, I get -1x. I get -4 is equal to -4. 1 minus 1 eliminates. So we're left with -4 equals -4. Is that true or false? That's true. You can write all real numbers. Now sometimes you'll see online this symbol to represent that as well. That works too. You just can't type that symbol into WebWork or some My Math Labs, things like that. All right, example 3. I'm not going to use substitution. I am going to use elimination. It looks like 6 can go into 12 and 2 can go into 4. I'll do 2 and 4 because they're smaller. So I'm going to multiply by 2 here, but then I need it to be negative so that I can get rid of that. So it's going to give me -12x, -4y, and +12. You might have an idea of what's going to happen here. These eliminate. Make sure you bring down that 0 is equal to -16, and that would be no solution. We'll do one more together. All right, 8 does not go into 28, 4 does not go into 14, so we will flip-flop our answers. I'm going to use the y's again just because 28 is so big. I'm going to flip-flop the 14 here and the 4 here. They're already opposite, so I don't need to bring any negatives. And I'm going to distribute here, and I'm going to distribute here as well. Feel free to pause the video and give this a try on your own, and then click back in when you're ready to see the answers. We get -112x, 14 times 4 gives us +56y, and -8 times 14 gives us -112. 4 times 28 gives us 112. Oh, something interesting is going to happen. 4 times 14, we know that's going to give us a -56y. And 4 times 28 gives us 112. All right, so these eliminate. Now, just be careful. Don't eliminate everything and say no solution. Yes, everything eliminates, but we need some placeholders here. So we got 0 on this side, 0 on this side. This is actually true. We're going to end up with all real numbers. All right, we've got 4 examples for you here. Not all of them are special cases, so I will tell you that one of these you will get a one solution answer. Press play when you're ready to see my work. Numbers 1 and 2, and numbers 3 and 4. And that concludes the video on special cases of systems of equations.